Next in the IX slot, as I want to mention it, is SEECIX and its news. Although I'm not really sure, is it SEECIX, is it DKIX? We'll have to figure this out. Teresa, it's both, huh? Welcome.
I was actually advised strictly by Andreas not to say any commercial discussions. So I'm just going to make a quick update, probably less than a minute. And my friend George is smiling at me. So we just wanted to give you an update on what is actually happening now with DKIX or SEECIX in Athens. So as you all know, SEECIX was previously managed and operated by DRT, the data center where it's presently located. Effective November 1, we will actually, or DKIX, will actually be then transitioning all the existing customers to DKIX, and the legal contractual obligation will then owned by DKIX. So it means to say it will no longer be operated by DRT, but it will be operated by DKIX itself. So it will be owned, managed, operate, and it will be sold by DKIX as well. That's the only word as far as commercial is concerned, Andreas. So there will be, as you know, we believe DKIX, or not DKIX, SEECIX in Athens play a crucial role as the digital hub in the whole of Southern Europe for enabling the exchange of traffic both regionally and also globally. So as compared to GRIX by Anthony's, it's not a free IX, it's a commercial IX, because there's a lot of advantages and benefits that you can look into this. As I'm not a very technical person to discuss about that, I will have my colleague, who is a peering guru, as I call him personally, Bernd will actually then go through that and go to all the enhanced services that all of you will get by connecting to DKIX at the DRT data center. All right, Bernd, it's all yours now. I don't know how to move it forward. All right.
Too far forward.
Is it too far forward?
I will make it.
All right. Thank you, guys. And my name is Teresa.
All right. Thanks, everyone. Thanks to the program committee for having me. Thanks also for the amazing buffet. It was really good. So I was asked to talk a bit about the other things. So as peering is quite present in the talks here, so the ask was about other services, what else is there, what internet exchanges like DKIX are doing. So let's have a look on this. So when we look at the DKIX website, we find beside pure peering a lot of other services and categories. Maybe also to mention there are a lot of people working behind, so DKIX in total has around about 300 people, and most of them are engineers who are taking care that these things are working. So especially I want to talk a bit about the topics my colleagues are representing. So we will look a bit into these things like closed user groups, Microsoft Azure Peering Service. There will be a quick look on this Google side of things, as well as this thing called Direct Cloud Router, and these connectivity options. Another thing which also comes partly into the picture, but it's not part of this presentation, when talking about these things and talking with enterprises, there is a heavy usage of things like API usage or MACsec or all these things aside. So maybe first to start a bit with the question, why are enterprises coming to internet exchanges? So because they are more or less the target group for these services, and also to mention this is not purely about DKIX purely going just to enterprises. This is of course also to utilize the business of the current ISPs, which are using this for for reselling. So we make it easy for the existing partners to use these enterprise services for their own usage. So when we look at what are enterprises asking for or looking for, so of course you find things like secure, fast, efficient, compliant, so all those things which are logically expected. But let's make maybe some controversial questions. So why are enterprises coming to internet exchanges directly, and maybe ask some questions. If we think on large internet service providers who are typically serving enterprise customers, so are they low latency focused always? So is low latency key each and every time? Dense and redundant peering, maybe for Greece. The question is, beside peering in Athens, how good is Greece to maybe use Thessaloniki or Crete to run the whole internet peering aside of Athens? So what I can tell you from Austria, if you take Vienna down, then the internet in Austria is gone for sure. So there is no survival of internet traffic in my hometown, which is Klagenfurt, not in Graz, not in Salzburg, not in Linz. We are fully dependent on Vienna. Or latest equipment is in place. Is this on the latest needed feature sets? Spare bandwidth given at scale. So are ISPs able, whatever comes in, Champions League or Olympic Games or whatever disasters where people use the internet, can they scale peering also on a second node, as we have seen in these outage scenarios, if C cables are breaking, if the primary peering handover hub is failing, is there enough bandwidth to the second one? Or experienced senior engineers, are senior engineers still on all the stages, or maybe not? And deliver what marketing and sales are promising. Also, this is a question if this is given. Or engineers, and this here is, of course, a nice attendance. So are engineers using the global meetings? So this is a bit some of the question. Of course, this is not a full catalog of questions, just some random question, but I think these are important questions which should be covered if you want to serve an enterprise with their needs very well. If not, okay, then maybe these things can have an issue, and maybe that could motivate the one or other enterprise customers to go to IXPs directly, or to their ISPs to ask for reselling of IX services. So let's look a bit into the enterprise things to get a bit used to these services which we want to look at. So of course enterprises are typically in this as a service world. So on the left side we have infrastructure as a service. So this is classically somebody rents a VM and needs a private tunnel into this VM. This is classically what we know as ExpressRoute, for example, from Microsoft, or things like that. So this is always a private connection to a VM or something similar. In the middle we have a platform as a service, and on the right side software as a service, so classically Microsoft 365 and those things. So on the left side the solution goes into direct cloud services. On the right side we are looking into these things like peering for enterprises or Microsoft Maps. Let's have a look at Microsoft Maps. What does this mean? On the bottom you see the classical way. So the enterprise is on the right upper side here, having an internet service provider. The internet service provider is using whatever IP transit connectivity, or one layer above, a direct peering over the exchange, and this does the job. So what Microsoft said, dear enterprises, please come with your direct network, with your direct ASN, peer with me, but please don't come via an IXP to me. Microsoft invented this Microsoft Maps product. And let me just simply jump to one slide forward to have a look on these technical details. So this is meant that an enterprise customers run their own BGP, has their own ASN. The map service is built from our side and also from our colleagues who are also offering this. There is a route reflector, a route server already running. This is pre-configured. This already has a session with Microsoft. Microsoft gives the full AS8075 to the setup. So this is the full Microsoft global peering. And in the moment where an enterprise customer is using this service, peers with the route reflectors, then automatically you have the full peering AS to AS with Microsoft in place. On top of it, it is a full end-to-end SLA coverage. It is fully in the portal available, so enterprise customers know whom to call if something fails, what to check when SLA questions are raised, and especially they have their own possibilities for the traffic engineering to really keep the traffic with Microsoft on these paths. Important is this does not outcarve the ISP, because the ISP is typically the one who is selling the layer 2 circuit to our platform. So this is just an exchange of a different service. But the nice thing about the layer 2 circuit is this typically has a fixed design, a fixed bandwidth, is not reacting on traffic engineering, session up, session down. Other cities are taking over. So the layer 2 typically stays where it is, has a defined latency. So for an enterprise, this is really predictable what's coming out. Other services, for example, Microsoft ExpressRoute. I think most of you have heard this or know this. So it is more or less the same, and the same you will see multiple times here. So it is always the SEECIX connection, or similar with our competitors and colleagues who are also doing these things. So the Internet Exchange is offering this link. The Microsoft Azure is pre-installed, or the ports are pre-installed, of course. So whenever a customer needs an express route and is already on a SEECIX system, then it is simply just one configuration which is needed, and then you have your express route circuit. Similar with AWS, yeah, it's the same drawing. The only difference is that Microsoft demands redundancy by design, which is optional with the others here. So AWS, the platform in between is pre-installed, pre-cabled to AWS. And if you need a private connection to AWS, then it's simply just a configuration. Google Cloud, same thing, same drawing, same platform. When you need Google, then it's a configuration. Oracle, Fast Connect, same drawing. If the customer needs Oracle, it's a configuration. So this makes it simplified for enterprise customers to instantly use whatever is needed directly, or maybe via an ISP, or maybe via you as a reseller of these things. So what does the enterprise need for that? Yes, enterprises should look and go into having an ASN, having IP, BGP device. So system integrators are also invited to help enterprise customers for those setups. So maybe also needful for multi-homing or redundancy as well. So that is one need. And then the question, okay, I am the ISP. I already have the peerings, so maybe some thoughts on this question here. So looking into Microsoft, we know from enterprise customers, Microsoft traffic can be at a level of around about 60% on enterprises traffic, what they are running. So this is quite not less. Enterprises also have needs to be DDoS safe or DDoS aware, and this also creates cost on the transit side of things. So we have quite a lot of enterprise customers who say, okay, Microsoft for me is a trusted network, so I trust the Microsoft peering that I directly connect this network to my network. And by doing this, they can put 60% of their traffic, what they have with Microsoft 365, on a map service and don't need to worry about DDoS protection on that service, for example. Or second, the latency question. So as enterprises are having a lot of real-time communication, virtual desktop, Microsoft Teams, are all these things. So they are very critical to latency. Microsoft defined bring the enterprise customer in 10 milliseconds RTT to my next Microsoft Edge router. If the enterprise has multiple locations, then split it up and bring each location to the nearest Microsoft Edge router in 10 milliseconds. So this is really caring about the physical close-by setup, which enables that the applications of the enterprises work better. So multi-cloud is another question, what to do with that. And let's imagine this scenario here, that we have an enterprise, for example, having a database on Oracle Cloud, an application maybe on Microsoft Azure, and maybe the web playout runs on Alibaba Cloud. So how to interconnect all these things. And classically, the enterprise would have built these all to the headquarter, which is maybe not the best idea, because the path from the Oracle Cloud to the headquarter to make a loop and bring the data back to Microsoft Azure and then bring it again to the data center and bring it back to the Alibaba playout system. So maybe this is not the most efficient way if it is about milliseconds and throughput. So this is where things like a cloud router comes into the game. So our platform, and let me use this slide here. So in the middle, this is symbolizing the cloud router. The cloud router is simply said a VRF instance in the powerful Nokia router. So this is all built-in hardware. So this can be scaled to terabit if customers want. And no matter what Cloud Connect is used, if it's Microsoft Azure or Oracle or AWS or AliCloud or whatever, this is in wire speed on a platform with multiple instances, with redundancy. So this is all run by silicon, by Nokia routers in a capsulated instance, which is then making the shortcut that data flows directly and not jumping to a headquarter of an enterprise customer. Very quick, the Google question, we have the Google VPP, so this presentation would fill an own presentation of itself, so this is very short. So Google had a lot of changes in their peering doing. So Google invented this thing, what is Google VPP, because Google is stepping back or changed their model of what they do on internet exchanges. So Google turned away from route servers. Google also denies new sessions for new asks. So Google said, okay, there is this product which is called VPP. VPP is available on transit carriers. So I think, I guess Vodafone sitting in the room is having VPP, correct? Yes. Same as DKIX does, or also others have invented. So VPP is the shortcut, or maybe this direct jump from Google to an enterprise customer, or whatever ASN, doesn't need to be an enterprise. And finally, closed user group, maybe also to mention this. So imagine an enterprise with a lot of locations, with headquarters, with other facilities or production places, with a lot of suppliers which run their own BGP instances. So as we are all convinced about peering, and you hear also peering 3 more times after me. So peering is something which we trust, which is reliable since more than 30 years. So why not use peering for that things? And of course, peering not in a public way, in a capsulated way. And this is more or less the idea behind what we call a closed user group, but we know similar approaches on other platforms. So this basically means you spawn an internet exchange environment, virtually capsuled for enterprise customers, that they can run their own peering with themselves, with different brands, or with their partners. The challenges, and that's my last slide, if you run with enterprises, maybe you're faced with these one or the other topics here. So enterprise customers will ask, as we had already the question from Otto, how about SLA, how about 24/7, how about penalty fees if something goes wrong? Complex processes, legal questions, insurance, reporting, escalation, different skill set on the enterprise. It's not like a wholesale customer. Complicated onboarding scenarios, decision cycles which takes years, planning phases, implementation. System integrators are also playing a role in this environment as well. But at the end, you have happy enterprises because it's really working well. And that's it from my side. Thank you.
Any questions?
Hi, this is Yannis Tsopokis. I want to ask you, I saw also someone from Vodafone Global here. What is the status between DKIX and Vodafone Germany? There is some changes there. I think they were connected to you and now they are not. Do you know?
Maybe you want to answer this? Ben or Otto? Ben?
So I think there's going to be an announcement very shortly as well on the next slides about what we're doing here in Greece. Yes, we are partnering with the likes of Interlink in Germany. We will be pulling back, very similar to the Google VPP, from the main exchanges. But I will stress we are not leaving entirely. We will be maintaining access, and this is the same thing for all our domestic ASNs. They will still maintain access for educational, good of the internet, non-for-profits, within those exchanges, still being part of that community, but the majority of the kind of commercial sessions are being backed onto a reseller. In this case, in Germany, it's Interlink.
Perfect. Any other question? Erotis, Alice?
Thank you.
Thank you.